This is Algebra 2 at Trig, 8C.1a. We're talking about law of sines. Well, with law of sines, you have information that's given to you in terms of angles and sides. And if that information is in the pattern of angle-angle side or angle-side angle, and in some cases side-side angle, then we can use law of sines. Law of sines is written as three separate ratios: a over sine of a, b over sine of b, c over sine of c. And using our proportion rules, we can also write it as sine of a over a, sine of b over side b, sine of c over side c. Notice that the lowercase letters represent sides and the uppercase letters represent angles. Something else to realize is that when your triangle is written as angle A, angle B, angle C, side A is across from angle A. Side B is always across from angle B, and therefore side C is across from angle C. So when we come down here, we're told that we can use law of sines for angle-angle side. Here we have two angles and a side. We can see, does this S land in between the A's or does the S land outside the A's? When you draw your picture, because I'm noticing there's an obtuse angle, I'm going to place the obtuse angle in the lower left-hand corner. It just helps with organization. B and A, it really doesn't matter which spot that you put your B in the A, but I often like to put my second angle in the upper side here. So that's 34. So where am I going to put the 8? It's going to be between C and A. It's going to be across from angle B. That's what we meant about side B has to be across from angle B. Very important, you know where the different sides go. So to use law of sines, you can remember this: angle, angle, side, angle, in some cases SSA. You notice here that we have two A's and the S, the side. The side is not between the A's, so this is falling into the pattern of angle, angle, side. You can remember these patterns, but it might just be easier to think about it as, do you know two bits of information for one of the letters? We know the angle and we know the side for B. We know side B, we know angle B. Because we know two bits of information for the same letter, we can use law of sines because we can fill up a complete fraction. So we're looking for angle A, we're looking for side A, and looking for side C. Which do you think we're going to look for first? You got some choices. Look for side C? Okay, we have the angle C, so we're looking for side C, and we have to use B. So what I would suggest is to first write it out using the letters. Just gets you organized, gets you thinking about what are you doing, where are you pulling your numbers from. You can't pull them just from anywhere. So, side B is 8. Angle B is 34, so it's 8 over sine of 34 equals C over the sine of 100. So we're going to cross multiply. Notice I'm only going to cross multiply in one direction because my unknown is already on top of the fraction. There's no need to multiply my sine of 34 and then divide my sine of 34 back again. So I'm just going to multiply 8 sine of 100 divided by sine of 34. And that's going to equal my side C. So you need to be sure you are in the correct mode. So by hitting mode, you got to be in degrees if we're going to talk about degrees. So 8 sine of 100, close your parenthesis, divided by sine of 34. You can close it if you want, doesn't matter here. Hit enter, and we get 14.09, because we'll round the 0.8 up to a 0.9. 14.09, that was the length of C. And does that make some sense? Yeah. The larger angle across from it is going to be the longer side. 14.9 is longer than 8. 34 is less than 100. So 8 is less than 14.9. The longest side is across from the longest angle. The smallest side is across from the smallest angle. Oh, 0.9, isn't it? Thank you for pointing that out. I got stuck in here on what I was writing and I lost it. Thanks for pointing that out. Okay, what are we going to do next?
You have to work backwards with the
Pythagorean theorem, perhaps? Pythagorean theorem is going to require us to have a right triangle. And we don't have a right triangle. Notice here that law of sines, maybe we didn't mention this earlier, law of sines, what's special about law of sines is that you can use it for any type of triangle.
Is that why you can't use SOHCAHTOA?
We're not using SOHCAHTOA because that requires a right triangle.
That makes sense.
Very important information to bring forth. This is kind of advanced above SOHCAHTOA. You can use this for a right triangle. So great, law of sines is great to use, even in place of SOHCAHTOA. You can use it in any of those situations. But what's special about it is it doesn't require a right triangle. So we have both information for B, we have both information for C. Now we need to have some information for A. So what can we solve for A? You got to make a decision. How would you do that? What do you know? You can solve for angle A, and how are you going to do that? Nice job. We're going to subtract, because we know two angles. You could have done this in the very beginning, but because we know two angles, we're going to subtract them from 180 because the total angles in a triangle we know is 180. We can subtract 100, and then we're going to subtract the 34. And we get 46. And you want to label your work. It's the measure of angle A. That was 46. Now we have the angle. Now we have one of the parts of our A fraction. The trouble here in the beginning is we didn't have side A and we didn't have angle A, so we couldn't use this ratio at all. We didn't know either one of them. So we had to do some subtracting from 180 to help us figure out the angle. Now we can use law of sines to solve for side A. So of course we're going to use the fraction or the ratio for B, because that's the two bits of information that they gave us originally. I would always suggest that. And we're going to use the fraction for A because that's what we're looking for. So we can plug in our 8 and our sine of B, which is sine of 34. A is what we don't know, so we use a lowercase a. And its angle is sine of 46. So the rest of it should be pretty straightforward. We're going to cross multiply, multiplying by the sine of 46 up to the 8. This is the work that you need to show. Don't skip this work and just say, I type it in my calculator. Show what you're typing into your calculator. 8 sine of 46, close your parenthesis, divided by sine of 34, and that gives us 10.29. So up here in the picture, I like to write 10.29 and circle that. So those were the 3 things that we solved for. These were the 3 things that we have our calculations for. So over here, we have the measure of angle A, the measure of angle B. I notice that the 2 angles themselves are adding up to be greater than 90, so I know the third one has to be less than 90 also. So I'm going to have an acute triangle. Doesn't really matter how you draw your acute triangle. I can label these in pretty much any order I want. Doesn't matter. I typically will always write an angle in my lower left-hand corner. And if I have an extra angle, I'll do that one to the top. So side A goes over here. Side B goes down here. Therefore, side C is going to be across from angle C. That's going to be here. So notice the pattern that we have now. A is 51 degrees and B is 44 degrees. So we have it as angle, side, angle. The side that they give us is in between the 2 A's. Now, what we talked about before, we needed 2 bits of information for the same letter to use law of sines. Angle A, I have to have side A, but I don't know side A, so I can't use that ratio. B, I know angle B, but I don't know side B, so I can't use that ratio from law of sines.
Oh my gosh.
Now, what about C? I know the side, but I don't know the angle. Because you know 2 angles, you can subtract from 180. Nice job. So we'll minus 51. So that's 129 minus 44. Gives us 85. So we have the measure of angle C taken care of. Now you notice that C is the letter that we know both bits of information for. So we can use law of sines. In the future, you're going to ask, how do we know which method to use? Well, we use law of sines if we have 2 bits of information from the same letter. Do we have the side and its angle? This didn't look like we did. We had to do a little calculation for us to figuring it out. But it was pretty basic. It'll just be from 180, and we did that. So now we can use the C fraction. And we can solve for either one of the sides. It doesn't matter which one. So I'll solve for side A. So C is 11. Sine of C, sine of 85, equals side A over the sine of 51. And as usual, we cross multiply. And that's going to give us our value of side A. Close your parenthesis, divided by sine of 85. That gives us 8.58. So side A was 8.58. So looking at what we know, if you're labeling your triangle with information, I like to circle the information that I've calculated. I like to circle it in my work. Now it's clearly that I need side B. I'm going to use the C fraction and, of course, the B fraction. I use the C fraction because I know both of its information, 11 and sine of 85. And I'm going to use the B fraction because I'm looking for side B, but I have angle B. So I'm going to cross multiply. That's 11 times the sine of 44 divided by the sine of 85. Order matters. So 11 times the sine of 44, close your parenthesis, divided by the sine of 85. You can close it if you want to. And you'll get 7.67. We can label that up here and circle it. And we solved our right triangle. Notice we cannot use SOHCAHTOA. You cannot use Pythagorean theorem if you don't have a right triangle. Last one here. This has an obtuse angle in it. So I'm going to put it down here on this side. It has a side that we're given. So that has to be across from angle B. Now where should we put C? Well, notice here, they're giving us an angle, they're giving us a side, and they're giving us another side. So we could write it in either spot. In the future, we're always going to build it kind of in a clockwise fashion, moving off to the left and around. It makes the drawings a lot easier to represent what's going on. So I would put this C right over here. Not that it's a requirement, but it could help future planning. So if that's angle B, and that's side C, so this has to be angle C, and of course side B is across from it. So notice that this is angle side side, ASS. You should recall that from geometry class, we had issues when we worked with angle side side. And that's because more than one thing can occur in this situation. Because this is an obtuse angle, and the side opposite is larger than the one that it's next to, there's only one triangle that we can possibly make. With these numbers, in this order, there's only one triangle that's possible. Tomorrow we're going to discuss how you can actually make multiple triangles out of information given to you. But in this situation, we're good to go. So as long as it's obtuse and the side across is bigger than the side adjacent, we can move on. What are we going to solve for? We're going to solve for angle C. Now, some people might say, well, why don't we solve for angle A? You can't solve for angle A if you don't know side A. We can solve for angle C because we have side C. And of course, we have to use the B fraction. So we're going to use the B fraction. And we're going to use the C fraction. Now notice that I wrote my sides on top and my signs on bottom. You could flip that if you're observant to it. If you know what you're doing and you know that you're solving for a sine of C, you can switch that. You can do sine of B over B and sine of C over C. That is just fine. It doesn't matter. It's a property with proportions. It will save you a step. So if you like to be advanced, you like to recognize the best way to set up your equation, this would be the best one to use. B is 104, so this is the sine of 104 over 25. We're solving for sine of C, so notice that's now on top of the fraction. And that's where your solving part has to be. It has to be on top of the fraction, so that's the advantage of doing the reciprocal. And C was 18. So when we cross multiply, we only have to cross multiply one direction. Just saves you a step. So we have 18 sine of 104 over 25. And this is going to give us the sine of C. So what type of answer are we expecting? Sine of C should equal maybe what? It should be a pretty small number. Thinking about what we've known in the past, from our unit circle, the sine value is going to be between a maximum of 1 and a minimum of -1. You're not going to get an answer like 14. Sine of C isn't going to equal a larger number. It's not the angle yet. It's just what this ratio equals. So it's 18. Gotta turn it on first. 18 sine of 104, close your parenthesis, divided by 25. And you get 0.6986. Now this is just what the sine of C is. This isn't the angle value, of course. So don't say this is your angle. How do we figure out what angle gives us a sine of 0.69? When we think about this, we know that half is right here, and 0.6986 is going to be a teeny bit higher. So the angle is going to be whatever this is out there. That's going to be your angle that we're trying to come up with. How do we determine what the angle is if your y value is 0.6986? What do we do to solve for an angle? Sine inverse is 0.6986. Sine inverse Now, better than putting down 0.6986 is to use answer. Type in the whole value. And we get our 4432. That's the measure of angle C. We did it. That angle should be bigger than 1. We wouldn't expect an angle to be super teeny. 44.32. Circle that in your picture. Alright, so now I know 2 bits of information for B. I know 2 information for C. But I don't know anything for A. I can't use law of sines unless I know one of the parts. We can solve for the angle by subtracting from 180. 180 minus 104 minus 44.32. 180 minus 104 minus our previous answer. Here it barely matters, but might as well use it when we're used to it. 3168. So this angle is calculated. That's the measurement of angle A. Label your work. What did you find? Now what are we looking for? So of course we're going to use the fraction. I'll do it over here. I got a little bit more room. I'm going to use the A fraction because that's what we're solving for. We're solving for A, and I'll put the side on top because that's what we're looking for. The B fraction, because that's the 2 bits of information that they gave us originally. So I think that's better than using C. But it really wouldn't matter. You can use C if you wanted to. So 25 over the sine of 104 equals A over the sine of 3168. Not my favorite thing to use work that we've calculated, but when you have to, you have to. It's okay in this situation to not use the answer button. If you can get your calculator and follow that along, I do have it as my last calculation here, so I could probably get away with that. Cross multiply in one direction. 25 sine of 31.68 over sine of 104. That equals value of A. So we've got 25 times the sine. Now, because 3168 was the last thing we typed in, you could use the answer button. That would be outstanding to use. But I'll be okay if you use a rounded. We'll try to see if there's much of a difference. I wouldn't expect there to be one here. So we have 13.53. So if we did that value and we did sine inverse, so we got our, that's not the one I expected. Doesn't matter, just playing around. So that's our 13.53. And we saw for all 3 angles total we have and all 3 sides now we have. Something we're going to look on in the future, tomorrow, we're going to talk about this chart. We need to be aware of this chart a little bit. So this is your first experience with what's going on with deciding what happens with side-side angle situations. Today, we had a situation where we had an angle side was the information they gave us. Because the side opposite was larger than the side adjacent, A was greater than B, we had one triangle that was made. Notice here that if A is specifically less than B, if it's less than B, if B, let's write it in the same pattern we have here. A is less than B, then you're going to have no triangle B formed because this A length is not long enough to reach the end. We'll learn about this more tomorrow. Then you come over here with an acute angle. We didn't have that today because it brings up this whole concern. If the opposite side is long enough, you don't have any issues. If the opposite side is smaller than B and greater than H, that's where you have this issue of that it can be in two different spots. You can create two triangles. We'll talk about that more in the future.